Welcome to today's lecture. It is Wednesday, March the 18th. Today we're just going to do some synthesis approach. Okay, so we'll work on about, we're going to synthesize two molecules, and we'll talk about that approach. The other thing we will do today is I will provide you with one question at the end, and it will follow the same kind of methodology. Some people have been turning in their daily POGIL questions, which is great. I've been scoring a 2 out of 2. So it'd be 2 out of 2 for Monday, 2 out of 2 for Tuesday, and then today would be a 1 out of 1. That gives you 5 online POGIL points. The other thing that would be due, and this is all due Thursday. Thursday is your Quizam 3. And you also Thursday you need to just print out the Quizam 3 wrapper. So it's just that Excel sheet, should just be one page. You just need to take that image and upload it. On the subject, you need to write CHE 314, and then you can put Quizam 3 wrapper, and then your name. For your POGIL, you do CH3 314 online POGIL, PG, and then your name. And then you also will have to download on Thursday the Quizam 3. You want to print it out, you want to work it. I'll post it at by 8 a.m. Thursday morning, and I will stop collecting it by 5 p.m. Thursday evening. Okay, I'm going to give you a full day, so go ahead and do that early in case you have IT issues. Okay, I will actually, for the feedback on that, we're going to go old style, right? I'm going to actually download them. So I need them to be in files, not pictures. Okay, I cannot download them. If they're a picture, I need to download. Otherwise, you're not going to get it graded the same way. Okay, you won't get it back. Or it will give you a score and just say problem number 1 is wrong, problem number 2, and tell you. But your feedback will download. I will print it out. I will grade. I will rescan, upload, and I will send you it back. Okay. Now this will not be part of the replacement. So we are making some changes, right? And due to this coronavirus circumstances. The other thing, I will post keys. Hopefully today I can post some keys for the take-home quiz. And I will also post keys. That's it. Just post. I will for the take-home quiz, and then on Friday I will post the key to the Quizam 3. Now, one final note. So you will not have any no video. There will be no video on Thursday. So Thursday you basically print off the exam and you take it, and then you resubmit it. Okay. Now, you all know that this is kind of like a drawing class. I use sophisticated ChemDraw. Have to pay money for ChemDraw. I put those images in your exams. So I've tried to do Canvas. I've made images. I've tried to incorporate them in for a Canvas quiz, but it literally cost, my computer crashed twice. So I'm not convinced of that. So that's why we have to do it this way, because we have images, pictures, and I need to see that you can draw those pictures. If we end up going online for the whole semester, which UK just announced that they are, I would assume we probably are. I might start writing your next quizam and stuff in sapling. So if you're doing sapling, um, get prepared. You might end up doing the quizam and I'll rewrite it. If we do this, I will rewrite your syllabus to let you know how we're going to do the rest of the semester. But all I would see is a quizam 4 and a final exam. So after this, if we end up going online the whole way, we're just going to have a quizam 4 and a final exam because there will be no replacement. And your final exam will not be ACS, okay? It'll still be multiple choice questions and stuff like that. Quizam 4, I don't know if we'll do it the same way we're doing it now. Quizam 4 will still be over the enols, okay? Quizam 4 will still be over the enolates and enols. And we'll talk about the difference between enols and enolates. We will be doing your POGLs. I got to go on campus. I'll just tell you, I'm going to probably be on there maybe on Friday. Can't guarantee it at this point, but I got to go back and get my POGL book, and I've left my resources there because I didn't expect this, right? I guess we all didn't expect this. Um, but I think it's 22. Is it POGL 22, A, B, and C? And just a heads up, you're going to be taking pictures and scanning those additional problems next week. And they'll be over the next 2 weeks. So that will be your POGL, and that's 15 points there, 5 per each. And then I'll probably incorporate some extra questions that you'll have to send in. I like these questions because they let me know that yes, you are listening to the lectures and showing up. So I wanted you to get benefit for that. Okay, so let's do synthesis. It's been kind of nice to just have a little bit of a review this week. You also have additional problems in the end of the chapter. Those are your best. That's how we write the exams. And I say we, I'm talking everybody that teaches organic chemistry. They choose those questions that have been reviewed from your textbooks. That's why your textbooks cost $300. Okay, so work those problems. You have the videos that tell you how to do it. Okay, so how would you synthesize this molecule? Benzene, it has a chlorine, and it has an ester. Now this is the key. You are allowed to use benzene and no other carbon starting material greater than 6 carbons. So you're going to use benzene. And then you see here, this is 1, 2, 3, 4, 5, 6. Okay, so you can't just put an ester on there. So what's your plan? I'm giving you time to think. I'm kind of thinking. Okay, well, how are these two related to each other? Is it ortho, para, or is it ortho? Oh my Pikeville. Ortho, meta, or para? Yes, it's para. Well, is the Cl a meta director or an ortho para director? Ortho para. Okay, so we can go ahead and install that, right? So how would we make this? What is that? Cl2 and like aluminum trichloride, right? Aluminum chloride, aluminum 3 chloride. All right, now we have this. This is a para director. Now, the best way to do this is install a nitrile. Okay, so let's figure this out. How do we go from a nitrile to an ester? And how do we go from a benzene ring to install a nitrile? Well, what 5 reactions did you learn for ease? electrophilic aromatic substitution. Now, you remember electrophilic aromatic substitution, the intermediate is that sigma complex, right? Well, you knew how to install an SO3H. You know how to install a nitro. You know how to install a ketone, Friedel's Craft, acylation. You know how to install a substituted carbon, right? That's Friedel's Craft alkylation. And then you learned how to put either a chlorine or a bromine on there. Remember, those were your 5 reactions. So this one's different. With this one, we are putting in the nitrile. So that is a Sandmeyer reaction. So let's go to this. We'll put the structure up here again. Our goal. Okay. So we already have this compound, correct? And our goal is to make the nitrile. So you remember how to do that. CM. Yeah, I said Sandmeyer. So Sandmeyer has to go from an aniline, NH2, and then you can go to the diazonium, salt, and then that does a weird kind of chemistry with copper cyanide. This is a leading group, so this becomes your nucleophile, and it's almost like an SN2, but it's not, because it's SN2 is on sp3 carbons. Okay. All right. Now, so how do we get to an aniline? We need to put the NH2 there. We don't know how to do that, but we know how to do a nitro. Okay. So if we take this compound here and we react it with HNO3 and H2SO4, because the chlorine is paradirector, we can get our nitro there, right? That's a nitration. NO2 plus is your electrophile. All right, and then we can reduce that. So we reduce that doing zinc, mercury, HCl, the Clemmensen reduction. All right, so that gives us the aniline, parachloroaniline, and then we can do diazonium salt, right? What is that? Sodium NO2, sodium nitrate, and HCl. Don't have to know the mechanism, but you do need to use it synthetically. Let's make sure diazonium salt, and now we can react it with copper chloride. CN. All right, now our next goal will be to go from the nitrile to the desired product, which is the ester. Okay, so we need to hydrolyze. We could hydrolyze this. So what can we do about nitriles? We know that we could add acid and water and heat, and this gets us the carboxylic acid. Okay, we know we could do dibal, right? And that gets us the aldehyde. And then we have a third reaction. What can we do? Lithium aluminum hydride. And that gets us the amine. Okay, so which one we want to do? For this one, we're making an ester. So the best bet will go right here. All right, and so once we get the carboxylic acid, we can do thionyl chloride. It gives us an acid chloride. We know from an acid chloride, then we can go and add our 6-carbon alcohol, right? And this would give us the product. Now, we could also do the Fischer esterification, right? So you could do this one, which is a equilibrium arrow. And then you would just need acid and the alcohol. And that would also give you your product. So either way would work. So that's a synthetic approach. You just kind of break it down and work it backwards from what you know. Let's try another one. And then I'll give you one that's worth a point that you can add. You can just put it at the bottom of your, well, you can add it to the other questions you have. Or you could put it at the bottom of your Quizam 3 wrapper that's due. All right, so let's make this compound. Here, I'll draw it again. Okay, so we have a fluoro compound that is got some carbons here. Okay, so this is a compound we want to make. How are they related? The substituents, the fluoro and then this carbon. They are meta to one another. Well, you know your fluoro compound is orthoparadirector. And once again, the same rules apply, but I'm going to give you the fragments you can use. So we're going to use the benzene ring. That's where we'll start. And you can also use an acid chloride. Okay, so 1, 2, 3 carbons. You can also use a nitrogen that has 3 carbons. Okay, and then you can use a sodium cyanide. Okay, so everything that you use has to have 3 carbons or less, not including benzene. So if you use these fragments, what would you do? Well, you know you got to start with benzene, and you need a meta-director to be added first. Now you have 5 reactions, 5 ease reactions, right? You got a nitration, you got this sulfonation, you have Friedels-Crafts. So if you put a carbonyl there for a ketone, Friedels-Crafts acylation, right? And then you also have Friedels-Crafts alkylation. And then you've got your chlorine or your bromine, but not a fluorine, okay? So what you can do is you can You could add your fluorine first. So that means you're going to have to start with a nitration. And then if I were you, I'd just keep it at the nitro. Okay. So then I would go ahead and just think of this nitro. I would think of this nitro as a masked fluorine group. All right. So the next one is going to add, you can do your acylation. Now, 1, 2, 3. There you go. Let's use this molecule right here. So that will be your 1, 2, 3 carbons. 1, 2, 3. And then what do you need? You need a Lewis acid. Okay. So there you've added your blue carbons, and you have a carbon, an ester, and an ester, a ketone. You have a ketone. Now, how are we going to add this group here? We can't do reductive amination, but we do have a carbon here. A carbon and a nitrogen. You see that? Here's your carbon and your nitrogen. So we have to get this added here. So what we can do is we can reduce this. And you can reduce it with sodium borohydride. And then what you'd have to do is you'd have to turn it into so let's go ahead and reduce that. To the alcohol, and then you can turn it into like PBr3, a good leaving group. Don't use acid and water because you'll get elimination. Okay, you'll get a, but like this will change into Br, or you could tosylate it. That would be tosyl chloride and pyridine. Okay, that would be another approach. So here we have this. Now we can react it with sodium cyanide. This is your SN2 reaction. Let's make these blue, and then let's make these green. So here's your C triple bond nitrogen. Now, going back up here to our molecule, we are trying to add this group here, and we have a nitrile. Is this a primary amine? No, so we're not going to do Gabriel. Gabriel is the phthalimide. It is a tertiary amine. So our best thing to do, we can either do acylation, nucleophilic acylation and then reduction, or we can do reductive amination. Okay, so if we did acylation, nucleophilic acyl substitution, then you'd have to go reduce, you wouldn't reduce, you would hydrolyze this to the carboxylic acid, and then you'd have to go with the thionyl chloride, and then you would react this with your secondary amine, and then you would do lithium aluminum hydride, and then you would get this compound here. There's your carbon, and then your amine would be nitrogen, CH3. Okay. Now, would this reduce in lithium aluminum hydride? Probably so, but just in case, use mercury, zinc mercury, HCl. That would reduce it. And H2. And then what do you do? Because remember, what does our compound have on it? A fluorine. So the steps would be 1 sodium nitrite and HCl, and then 2 HbF4, and that should give you your product. What if you wanted to take this compound and do reductive amination? So if you were going to do reductive amination, let's come over here, RA, reductive amination, you're going to have to reduce the nitrile to the aldehyde. Okay, so that reduces that to the nitrile, the aldehyde. We still have this here. And then reductive amination, you would just, first thing you would do is make the amine. So let's add NH, a little bit of acid, and then sodium, use a sodium cyanoborohydride. And then that will install, that will make this compound here. And you can go through the same process. Okay, so now let's do this one. I will let you, this is for your 1-point Pogel homework. So put this on your Quizam wrapper if you've already submitted some Pogels. This is for 1 point. I want you to show the synthesis, so show every step like I just did for this compound. Okay, so there's the fluorine there. And kind of looks very similar. So I will redraw this. CH3, CH2, CH3. Okay, now it's your turn. The first thing I would also look at is what's different. All right. I will see you all later. Tomorrow you'll have your Quizam 3. So keep up the